Next, we are going to learn how do we derive a relation or a formula involving various physical quantities using the knowledge of dimensions. Suppose we have a physical quantity like your x, which depends on other physical quantities like your y, z and m, which have powers a, b and c respectively. For example, we may write Newton's gravitational law like capital G m1 m2 by d square. Here f is a physical quantity, m is a physical quantity, mass 1, which depends where the power of m is 1, even the power of the second mass is your 1, and the power of your d here right now is 1 over d square, that is d to the power minus 2. So it's like writing y, z, m. Y is your m1, so power 1. Z is your m2, so power 1. M is like your distance between the two masses, so to the power minus 2. So how do we get to this relation using dimensions is what we are going to learn in this video. First of all, suppose let's take up an example where we are going to derive an expression or a formula or a relation for the time period, we have used a small t, of a simple pendulum which may depend upon mass of the bob, that is your small m, length of the pendulum bob, that is your small l, and the acceleration due to gravity, which is your small g. So here we start by writing time period of a simple pendulum depends on the mass of the bob to some power which we do not know, length of that bob to some power b that we do not know, acceleration to the power c that we do not know. Our job is to find this a, b and c. Now this proportionality sign you must have learned, we can remove it by equality sign by multiplying with a constant, where this k is going to be our dimensionless constant. What we do again is use the principle of homogeneity of dimensions. We write the dimension on the left hand side and we also write the dimension on the right hand side. So dimension on the left hand side is your t, because t represents time period, so we have this capital T for that. Your m here, if you remember, was your mass of the bob, so we have capital M as the dimension to the power a. L represents length of the bob, so L is the dimension with the power b, and g represents acceleration due to gravity, for which we have written Lt minus 2 to the power c. T is simply m to the power 0, L to the power 0 and t to the power 1. That means there is no m and no L. On the right hand side, this a we have written with m, so we have m to the power a. L we have written with b, so we have L to the power b. This L inside has power 1. The c gets multiplied with that 1, so we get L to the power c. And this twice c gets multiplied with this c, so we get L to the t to the power minus twice c. Now we again arrange our right hand side such that we have here L to the power b and L to the power c, which we arrange to get L to the power b plus c. So you see on the left hand side we have m, L, t. On the right hand side also we have m, L and t, and with corresponding powers. Now we know by principle of homogeneity of dimensions, the left hand side should be equal to right hand side in terms of dimensions. That means this 0 here with m should be equal to this a, that's why we got a equal to 0. This 0 with L should be equal to this b plus c, because power of L is 0 and power of L is here b plus c. So we get b plus c. Then we have t to the power 1, and here we have t to the power minus twice c. So we write minus twice c, this one must be equal to this one. From here we can find the value of c to be minus half, which we plug in into this equation here, so that we get b minus half equal to 0. So from here we have also got your b. So see, we have got your a, b and c. So now we are ready to write the final form. So we have t, which is the time period, equals to some dimensionless constant, m to the power a, which comes out to be 0, L to the power b, which comes out to be half, and c to the power minus half, so we have written g to the power minus half. M to the power 0 here simply means there is no m in this equation, so we simply write k. This power half means root, so we have root with L. This power minus half means root with g, but it should be on the denominator, so we have that. So we have got this equation here where we write a single root for your L by g. So see, here we got the formula for a time period depends upon directly the square root of your length of the bob and inversely on the acceleration due to gravity. So this is the method you are going to follow whenever you are going to derive the relation. But for that, what you need to remember is that you must know what does a given physical quantity, like a time period here in this case, depends upon. In this question, they've clearly mentioned the time period was depending upon the mass of the bob, the length of the bob, and acceleration due to gravity. But somehow we have seen that this time period does not depend on the length, so that's quite alright. And we have got this relation here. This k, as I've talked earlier, is a dimensionless constant, and it can be found experimentally, and it has been found to be equal to twice pi. That you do not need to write, so it's quite alright. Let's take up another example so that you become more clear with what we have been doing. Next, suppose we have a problem where they have given the velocity of transverse waves v on a string. If you remember, you have a string like in a guitar, and once you start playing, vibrations are set up in the guitar. So this guitar string, which is made to vibrate, is going to have some velocity, and that velocity, according to this question, depends upon the length of the string. That's the first thing they have given. Depends on the tension. Tension simply means with what force is the string being pulled on either side where it is fixed. So tension is simply your force. Then finally we have something called mass per unit length, m. One thing here to note for you is that this m here is not mass, but they have said it is mass per unit length. So you cannot take the dimension of this mass to be m, it must be m by L. So we need to derive the formula for your transverse waves velocity using the methods of dimensions. So just like before, we will write the velocity depends on the length of the string, tension on the string, mass per unit length of the string, to the power a, b and c, which we do not know. Again, you see we have brought the dimensionless constant, and then we are simply going to write dimensions on both sides. So we are going to write dimension of velocity, dimension of length to the power a, dimension of t to the power b, dimension of mass to the power c. Tension, as I told you, is force. So dimension of tension and force is same, that is your mlt minus 2. Dimension of v is here velocity, so we have lt minus 1. Dimension of this L here is L. Dimension of tension is written here. Dimension of m, be careful, we have written not mass but mass per unit length, that is your ml inverse. We then arrange, multiply this a with this L here, means it is the power for that, so we get L to the power a. This m will have a power b, L will have a power b, and this t will have a power minus twice b. Then finally the c will be multiplied for this power m, so we get m to the power c, L to the power minus c. Now we simply arrange m has a power of b, m has a power of c here, so we get m to the power b plus c. Then we have L here, L has a power a, L has a power b here, and L also has a power minus c. So we write L to the power a plus b minus c. Finally we have t here, which has a power of minus twice b. So once we write that, you can see on the left hand side is quite clear what are the powers of your MLT. On the right hand side we have in terms of a, b, c, we are simply going to find now a, b and c. For that we are going to say dimension of both sides must be same. That means whatever is the power of m here, that is your b plus c, must be equal to the power here, which is 0. So we have written b plus c must be equal to 0. Then a plus b minus c must be equal to this 1 here, so we have written that. And finally your minus twice b must be equal to this minus 1 here. The first thing what we can find is your b from here, because it doesn't involve any other unknown quantities. So once we get our b, we can plug this b over here as half, so that we get half plus c is equal to 0, such that we have got now c minus half. So we have got our b and c. We are going to put both b and c in this equation now, so that we can start getting our a. So we have put half for b minus half for c. So when we arrange this, we are going to get a equal to 0. So finally we are going to write our final equation, where if you remember we have written v equal to k L times of a, t times of b and m times of c. 0 means no L, of course. Then we have this half means root over of t, and minus half means 1 over root over of m. So we have derived the expression for your velocity, and this is how you should proceed.